Good morning to all of you. We are discussing the topic correlation and correlation coefficient. In our last class, we have been discussed in detail about this corollary or theorem and another theorem that if x and y are independent, then its covariance will be zero and correlation coefficient also will be zero. But converse is not true. That means if we have two uncorrelated variables, then these variables may not be independent. So from this example we have been concluded that if we have two uncorrelated random variables, it does not mean that they are independent. Okay, so in this class we are going to discuss about assumptions of underlying Karl Pearson correlation coefficient. Okay, see, from the book directly I am discussing those topics whatever inside your syllabus. Okay, now we have to start this. Okay, so let's start. So here you can say that it is Karl Pearson's correlation coefficient, or only you can say that Pearson's correlation coefficient. So these are the assumptions we have to consider for Pearsonian correlation coefficient R. What are the assumptions? The variables x and y under study are linearly related. Okay, in our last class we have been studied that the x and y, if not linearly related or correlated, it does not mean that they are independent. So this uh, correlation coefficient, or strictly for Pearson correlation coefficient, x and y under study, whatever the variable x and y we are going to be consider, are linearly related. Okay, in other words, the scatter diagram of the data will give a straight line curve, right? Whatever already we have been discussed. Each of variables is being affected by a large number of independent contributory causes of such a nature as to produce normal distribution. For example, variables or series relating to age, height, weight, supply, price, etc. conform to this assumption. So if we are going to consider age, height, weight and age, height, this type of relation, suppose I am going to consider x is the height and y is the weight, and the correlation between x and y, that has to be considered under Pearson's correlation coefficient. Okay. In other words, of Karl Pearson, the size of complex of organs or something measurable, the size of something measurable are determined by great variety of independent contributory causes. For example, climate, nourishment, physical training, and innumerable other causes which cannot be individually observed or their effect measured. That means here Karl Pearson correlation coefficient is going to measure when one parameter is depends on other. It is telling one parameter is depends upon other. Okay, which cannot be individually observed or their effect measured. Individual could not be observed. Karl Pearson further observes the variations in intensity of the contributory causes are small as compared with their absolute intensity, and these variations follow the normal law of distribution. Okay, so here maybe you are thinking that what are the things we have to you have to write down your note. I suggest that you just write down these 2 points, these two assumptions, which is important for your Karl Pearson correlation coefficient. These 2 points you have to write down. If you want, you can write these things. If you want, you can write this. Otherwise, you can leave this one. Okay. Next, third point is your third point. Third assumption, you can say that the forces are so operating on each variable series are not independent of each other but are related in a casual fashion. In other word, cause and effect relationship, which is most important line. This one is your most important line, that cause and effect relationship exists between two different forces operating on the item of two variable series or two random variables. You can write. So for third eye, you just starts from here. The cause direct, no need to write the first line. From here you have to start. The cause and effect relationship exists between different forces operating on the items of two random variables or series. These forces must be common to both the series. If operating forces are entirely independent of each other and not related to any fashion, there cannot be any correlation between the variables under study. That means overall, this third point is telling that if we are getting one type of effect somewhere, suppose we got some effect somewhere, there means for this effect there has to be any cause. Okay, there has to be one cause. The very simple example, that if this is your container and initially the pressure was P1, and after sometimes the pressure inside this container has been increased to P2, which is greater than that of the P1. That means this is my effect observed. So cause is what? I decreased the volume. Hence the pressure has been increased. So without any cause, effect could not be happen. That we know. So if there is exist any cause for an effect, at that time this Karl Pearson correlation coefficient is needed. Okay. So for this third point, you just write down only one sentence. It will be enough for you, that the cause and effect relationship must exist. Here you have to add one word, you have to use must exist between different forces operating on items of two random variables, or you have to write exist between two random variables. This much you can write also, no problem. So this is pressure is one random variable and here volume is one random variable. So pressure increases, that means volume decreases. So if pressure increases, we found the effect, that means the cause is volume decreases. So in one sentence you can write the cause and effect has to be relations must exist, relationship must exist between different forces operating on items of two random variables. See here, different forces operating on items. That means what? Some force has been applied on pressure, some force, that pressure increased. Some force has been applied on volume, that volume decreases. That means the agent which is increases the pressure, the agent which is decrease the volume, or you can say the agent or the force which changes the pressure inside the container, or you can say the agent or the force which changes the volume of the container. Only for that this sentence has been written. So I suggest that you just write for this third eye, you just write the cause and effect relationship must exist between different forces operating on the items of two variable series or two random variables. Don't write series, two random variables. Two random variables you have to write. Okay. And these things no need to write. For example, the correlation coefficient between the series of heights and incomes. Okay. And here, wait, up to this much. The force must be common to both the series. The force must be common to both the series. That means here, which is the agent changes the pressure, that agent only changes the volume. That means that common agent changes both this and this. Okay. That means I pressed this piston. At that time the force is what? I pressed this piston. At a time pressure increased, volume decreased. So if I am going to take pressure is your x, random variable x and volume is your random variable y, and I pressed or given the force from the top this side, and this force only, this common force at a time increase the pressure, decrease the volume. Okay, so here again I am going to tell to you that you have to write down for third eye, the cause and effect relationship must exist between different forces operating on the items of two random variables. Then these forces must be common to both the series. Both the series, here series means it is nothing but your values of random variables. Okay, to both the series, that means values of the random variables. That means, see, if I will put the pressure on the piston, here continuously pressure suppose increases from 2 to 4 to 6 to 8 like this, and volume suppose decreases from 100 to 50 to 25. So this is called the series. Okay, this is called the series of your, or the values of the corresponding to random variables. So this is the series. Okay, up to this much you have to write. Then what you have to write? If the operating forces are entirely independent of each other, if operating forces are independently of each other and not related in any fashion, then they cannot be any correlation between the variables under study. So up to this much you have to write for the third eye, and you have to put another paragraph for here. From if you have to put another paragraph. That means operating forces here, operating forces entirely independent. If operating forces are entirely independent of each other, not related in any fashion, they are cannot be any correlation between the variables under study. How this see for example, correlation coefficient between series of heights and incomes of individual. You got my point? That means if I am going to consider height is height is your random variable x, and income random variable y. So here height, series of height means if I will consider height increases, that means height of the portion increases means 5 to 6 to 7 to 8 feet. If I'm not 8, up to 7 you consider, up to 7 feet I will consider the increase of height of the portion, that from 5 to okay 4 to 5 to 6 to 7, this series I taken. It is not mean that the income will be increased from suppose 1 lakh to 2 lakh to 3 lakh to 4 lakh. No, it will be increased, because increasing income, what is the effort you have to give for the income? What is the effort? What is the effort, or what is the force for income? That force is not required to increase the height. You got my point? So here the force to increase the height, here force to increase the income, both are different. Both are different. Here the type of force or the way of force or effort you can say to increase the income is fully different. There is no correlation between force whatever you have to put to increase the height. Okay, so like that, here height and income both are uncorrelated things. Okay, likewise the series of marriage rate and rate of agricultural production in a country over a period of time. That means suppose we are going to consider rate of marriage of a month rate of marriage. For this, suppose this is January month, rate of marriage suppose mm, mm, 50 marriages for one day. Okay, okay, 50 not 50, just consider 10 marriages for one day. 10 marriages for one day. So suppose in the whole month, suppose 300 marriages, so averagely 10 marriages for one day. Okay, and you just consider in this January month the agricultural production. Suppose agricultural production is suppose 50 ton, anything. So a 50 ton of rice, suppose 50 ton of rice, or 50 ton of you can consider potato, suppose, or tomato you considered. Okay, so 50 tons tomato you produced in January month, where the rate of marriage is 10 for day 10. Okay, so here we found the suppose 50 ton has been, suppose we are going to consider 30 ton, 30 ton tomato in this January month, that means per day 1 ton, 1 ton. Okay, now we are going to consider that the marriage rate has been increased. Suppose in the February, month of February, the marriage rate increased doubles, that means 20 per 1 day, 20 marriages for 1 day. Can you say that due to this rate of increase, the production of the tomato will be increased? Will be increased. There is no correlation. Here what is the mindset or effort is required to increase the rate of the marriage or anything you can consider. So whatever the procedure or the chance, or you can you consider anything regarding that, some like that, from the January to February the rate of marriage has been increased. It is not mean that the production of tomato is going to be increased from 1 ton per day to 3 ton like this. It could not be. This is one variable and its corresponding force. This is another variable. Suppose y, its corresponding force F2, both are on correlated. Okay, both are on correlated. So you have to write down here, if operating from if you have to put a para, and up to this much you have to write period, up to over a period of time up to this much. No need to write C. Okay, no need to write C. These two example is enough. Okay, now, however, if any one of above cause, the value of R given a set of data is not zero, then such correlation termed as chance correlation or superficious or nonsense correlation. Okay. Suppose what it is told to us, this sentence told to us that suppose sometimes we found the correlation between this one, rate of increase of marriage and rate of increase of production of the agriculture. Somehow we found some type of relation. Okay, if we consider 5 months for this year, January, February, March, April, May, and here we found from in which, suppose January, February, March, April, May, up to January to March, suppose your marriage rate, rate of marriage is increased, and production of the agricultural production also increased. And from April to May, it is decreased. That means marriage rate is decreased and production is decreased. So here we found that they have some correlation between them. They have some correlation. But as we saw that the force or the agent for increasing the marriage rate and the agent which is increasing the rate of agricultural product, both are different, right? So if somebody somehow got a relation between these two random variables, then such correlation is called as chance. By chance it is correlated, like this we can say, by chance it is correlated, or spurious correlated, or nonsense correlation also we can say. So however, so here it is written, however, if any above cases means here we discuss two cases, no need to write this one. If you want you can write C also. If any of above cases, the value of R, that means here correlation coefficient is non-zero. See, this is one marriage rate is one incident, rate of agriculture production also another incident. They don't have correlation. So for this marriage rate and rate of agriculture, if we want to find out R, it will be give you the zero. But somehow, someday, somewhere, or by somebody, the R is non-zero, then such correlation termed as chance correlation or spurious or nonsense correlation. So here we have to stop our discussion today in this class. Next class we are going to go for the numericals only. We have to find out the correlation coefficient between x and y by using Karl Pearson correlation method or assumption. Okay, so thank you so much for watching this video. You watch this in which way I told that you have to maintain your note. You write down the note and ready for the next class. Thank you so much. Thank you.